Welcome everyone. Today we will learn how to use the discriminant to find unknown constants in a line or in a curve equation. Before we dive in, make sure you are familiar with solving quadratic equations and the discriminant b squared minus 4ac, which tells us the number and types of solutions. When b squared minus 4ac is greater than 0, means positive, then there are two real distinct roots, and the curve cuts the x-axis at two distinct points. In this case, where the coefficient of x squared is positive, the shape of the curve is like this, open upwards, and it intersects the x-axis at two distinct points. Here, in this case, the coefficient of x squared is negative, so there is a maximum curve, and it intersects at two distinct points. One is here and another one is here. If b squared minus 4ac is equal to 0, then there are two equal roots, and the curve cuts the x-axis at one distinct point. You can see here, when the coefficient of x squared is positive, the curve open upwards and it has minimum point. So this is the point where the curve intersects the x-axis. When the coefficient of x squared is negative, then the curve is a maximum curve and it intersects the x-axis at one point, which is shown here. When b squared minus 4ac is less than 0, means negative, then there are no real roots and the curve lies entirely above the x-axis or below the x-axis. You can see here, when the coefficient of x squared is positive, then the curve is a minimum curve and it lies above the x-axis. In case where the coefficient of x squared is negative, the curve is a maximum curve and it lies below the x-axis. Now we'll do intersection of a quadratic curve and a straight line. When a line intersects a quadratic curve, we solve the equations simultaneously. This results in a new quadratic equation. The nature of the roots of this equation tells us how the line intersects the curve. If there are 2 points of intersection, the line cuts the curve at two distinct points. You can see here from the diagram, the line is intersecting the curve at two distinct points. So in this case, we will take b squared minus 4ac as greater than 0. If there is 1 point of intersection, the line touches the curve at 1 point, and this means the line is tangent to the curve. So you can see this curve is intersecting the line at just 1 point. In this case, b squared minus 4ac is equal to 0. In case there is no point of intersection, the line does not intersect the curve. You can see the curve is above the line, and in this case, b squared minus 4ac is less than 0. Let's do some questions. Find the values of k for which y is equal to kx plus 1 is a tangent to the curve. As there are two equations given, and we have to find the values of k, which is there in the equation of line. So the first step is to solve these two equations simultaneously. We will get the quadratic equation, then we will apply b squared minus 4ac. And in this case, line is tangent to the curve, so b squared minus 4ac is equal to 0. So first we will solve these two equations simultaneously. As we have here y is equal to kx plus 1 and here y is equal to 2x squared plus x plus 3. So in this case, we can simply equate the values of y. So if we write y is equal to y, then we have 2x squared plus x plus 3 is equal to kx plus 1. Now we'll simplify it. 2x squared plus x minus kx plus 3 minus 1 is equal to 0. Then we have 2x squared. From here we can take x as common, so the coefficient of x is 1 minus k plus 2 is equal to 0. Now we will write down the values of a, b and c. So a is 2 here, b is 1 minus k and c is 2. Now we'll substitute the values of a, b and c in v squared minus 4ac is equal to 0. So 1 minus k whole square minus 4 into a, which is 2, into c, which is 2, is equal to 0. When we'll expand this, this will become 1 minus 2k plus k square. We apply here the identity a minus b whole square is equal to a square minus 2ab plus b square. Minus 4 multiplied by 2 multiplied by 2 is minus 16 is equal to 0. Then we will rearrange it. K square minus 2k minus 15 is equal to 0. We will do middle term breaking now. K square, when we will multiply minus 15 by k square, it is minus 15k square. And the factors of minus 15k square are minus 5k and plus 3k. When we will multiply minus 5k by 3k, we will get minus 15k square. And when we will simplify these two, we will get minus 2k. So we have here minus 5k plus 3k minus 15 is equal to 0. K is common. K minus 5 plus 3 is common. K minus 5 is equal to 0. So we have here k plus 3, k minus 5 is equal to 0. We have k plus 3 is equal to 0. K minus 5 is equal to 0. So k is equal to minus 3 and k is equal to 5. So these are the values of k for which this line will become tangent to the curve which is given in the equation. Let's do another question. Find the set of values of k for which the line y is equal to k minus x cuts the curve in two distinct points. When the line cuts the curve in two distinct points, means b squared minus 4ac is greater than 0. So first of all, we will solve these two equations simultaneously. We will substitute the value of y from here to this equation or the value of y from this equation to the equation of line. So we can write here x squared minus 7x plus 4 is equal to k minus x. We will simplify x squared minus 7x plus x plus 4 minus k is equal to 0. X square minus 6x plus 4 minus k is equal to 0. This is the simplified form of quadratic equation. We will write down the values of a, b, and c. A is 1, b is minus 6, and c is 4 minus k. Now we have to substitute these values in b squared minus 4ac is greater than 0. So minus 6 whole square minus 4 into 1 into 4 minus k is greater than 0. We'll simplify. Minus 6 square is 36. Minus 4 into 1 into 4 is minus 16. Minus 4 into 1 into minus k is plus 4k. Is greater than 0. Then 36 minus 16 is 20. So 20 plus 4k is greater than 0. And 4k is greater than minus 20. Now we will divide minus 20 by 4. So k is greater than minus 5. These are the set of values of k for which the line y is equal to k minus x cuts the curve y is equal to x squared minus 7x plus 4 in two distinct points. Let's do another question. Find the set of values of m for which the line y is equal to mx minus 5 does not intersect the curve y is equal to x squared minus 5x plus 4. Whenever it says the line does not intersect the curve, then we use b squared minus 4ac is less than 0. So first of all, we will solve these two equations simultaneously. We will equate both the y values. X squared minus 5x plus 4 is equal to mx minus 5. X squared minus 5x minus mx plus 4, and minus 5 will become plus 9, which is equal to 0. We can write it as x squared minus 5 minus m is the coefficient of x plus 9 is equal to 0. Now we will write the values of a, b, and c. A is 1, b is minus 5 minus m, and c is 9. Now we will apply b squared minus 4ac is less than 0. So minus 5 minus m whole square minus 4 into 1 into 9 is less than 0. We will expand this using identity. Whenever we have both the signs negative, then we have all the answers to be positive. A square to be positive, 2ab is to be positive, and b square is also to be positive. So when we will take square of 5, it will be 25. Then plus 5 into 2 into m plus 10m. And then m square, so it is plus m square. Minus 36 is less than 0. Now we'll simplify it. M square plus 10m minus 11 is less than 0. Now we'll make factors of minus 11m square in such a way that when we add or subtract, we get plus 10m. So we have here factors plus 11m and minus m, which will give the result as 10m when we'll subtract, and it will give the result as minus 11m square when we will multiply. Minus 11 is less than 0, m is common, m plus 11, minus 1 is common, m plus 11, which is less than 0. We have m minus 1 and m plus 11, which is less than 0. As it is a quadratic inequality, we cannot write m minus 1 is less than 0 and m plus 1 is less than 0. Instead, we take out roots. So m minus 1 is equal to 0 and m plus 11 is equal to 0. So m is equal to 1 and m is equal to minus 11. Now we will mark these on grid. We can consider 1 here. We can consider minus 11 here. And as we know, the coefficient of m square, this square term is positive. So the curve is to be a minimum curve. So we can sketch a curve like this. As the sign is less than 0, so we have to consider the part of the curve which is below the x-axis. So the values of x on this part of the curve lies in between minus 11 and 1. So these are the values of x which we have to consider. So we can write here m is greater than minus 11 and less than 1. These are the values of m for which the line does not intersect the curve. Let's do another question. Find the values of k for which y is equal to kx minus 10 intersects the curve x square plus y square is equal to 10x. Now it says intersects the curve. It's not mentioned whether it is intersecting at two distinct points or one point. In this case, we will use b square minus 4ac is greater than or equal to 0. So first of all, we will solve these two equations simultaneously. We have here y is equal to kx minus 10 and here x squared plus y squared is equal to 10x. So we will substitute the value of y from linear equation to the curve equation. So we have here x squared plus kx minus 10 whole square is equal to 10x. We will expand this bracket. We will get k square x square minus 20 kx plus 100. 10x will be taken to this side, so this will become minus 10x is equal to 0. We have applied here the identity a minus b whole square is equal to a square minus 2ab plus b square. Now we will rearrange x square plus k square x square minus 20kx minus 10x plus 100 is equal to 0. We can write it as 1 plus k square x square. 1 plus k square is the coefficient of x square. Then plus minus 20k minus 10 into x. Minus 20k minus 10 is the coefficient of x plus 100 is equal to 0. Now we will write down the values of a, b, and c. A is 1 plus k square. B is minus 20k minus 10. C is 100. Now we'll substitute these values in b square minus 4ac is greater than or equal to 0. So minus 20k minus 10 whole square minus 4 into a, which is 1 plus k square, into 100 is greater than or equal to 0. We'll expand this using identity as both the signs are negative. So all the signs in the expansion will be positive. So square of minus 20k is 400k square plus 20k into 10 into 2 is 400k. Square of 10 is 100. Minus 4 multiplied by 1 multiplied by 100 is minus 400. Minus 4 multiplied by k square multiplied by 100 is minus 400 k square, which is greater than or equal to 0. 400 k square and minus 400 k square is to be cancelled out. And we are left with 400k minus 300 is greater than or equal to 0. So 400k is greater than or equal to 300 and k is greater than or equal to 300 divided by 400. So k is greater than or equal to 3 upon 4 or 0.75. A quick recap. Solving simultaneously the equation of the curve with the equation of the line gives a quadratic equation of the form ax square plus bx plus c. The discriminant b square minus 4ac gives the information about the roots of the equation and also about the intersection of the curve with the line. So we can see here, when b square minus 4ac is greater than 0, the roots are real and distinct, and the line intersects the curve at two distinct points. When b square minus 4ac is equal to 0, then there are two equal roots and the line intersects the curve at one point, or we can say line is tangent to the curve. When b square minus 4ac is less than 0, means negative, then there are no real roots. And the line does not intersect the curve at any point. We can say there is no point of intersection. We can use b square minus 4ac is greater than equal to 0 when there are only real roots mentioned and it says the line intersects the curve. It's not mentioned whether the line is intersecting at two distinct points or just one point. Let's do some past paper questions. The line y is equal to 3x plus k is tangent to the curve x squared plus xy plus 16 is equal to 0. Find the possible values of k. If it says the line is tangent to the curve, it means that b square minus 4ac is equal to 0. So first of all, we will solve these two equations simultaneously. We will substitute the value of y in this equation. So we have x squared plus x into 3x plus k plus 16 is equal to 0. We'll simplify x squared plus 3x squared plus kx plus 16 is equal to 0. Finally, we have 4x squared plus kx plus 16 is equal to 0. Now we can write down the values of a, b, and c. A is 4, b is k, and c is 16. Now we'll substitute these values in b squared minus 4ac is equal to 0. So k squared minus 4 into 4 into 16 is equal to 0. Now we have k squared minus 256 is equal to 0. So k squared is equal to 256 and k is equal to square root of 256, which will be k is equal to plus minus 16. For each of these values of k, find the coordinates of the point of contact of the tangent with the curve. So we have got two values of k. K is plus minus 16. We will substitute this value in the quadratic form, which we have got after substitution. So we have 4x squared plus 16x plus 16 is equal to 0. So this is the equation where we have to substitute the value of k as plus 16 and another time as minus 16. Now we have to find the coordinates of the point of contact of the tangent with the curve. So we will solve this equation. We can solve it using identity. We can write it as 2x squared plus 2 into 2x into 4, then plus 4 squared. So we have here 2x plus 4 whole square is equal to 0. If we'll take square root on both sides, we will be left with 2x plus 4 is equal to 0. So x is equal to minus 2. If we will substitute here minus 16, then there will be a change in sign only. So the answer would be x is equal to plus 2. We don't need to solve it again. As we know, there will be only a change in sign. Now we have to substitute these values of x in the equation y is equal to 3x plus k. So y is equal to 3 into minus 2 plus 16. So y is equal to minus 6 plus 16, which will give us 10. So minus 2 and 10 are the coordinates. For another coordinate, we will substitute the value of x as 2 and value of k as minus 16. So we have 6 minus 16, which is equal to minus 10. So we have here 2 comma minus 10. These are the coordinates of the point of contact of the tangent with the curve. Let's do another past paper question. show that 2x squared plus 5x minus 3 can be written in the form a into x plus b whole square plus c, where a, b, and c are constants. We have to write this in completed square form. So first of all, we will take 2 as common. When we will take 2 as common, we will be left with x squared plus 5 upon 2x, and we will write minus 3 separately. Now we'll write it in completed square form. We'll take x from here. We will take sign from here. We will divide the coefficient of x by 2. So this will become 5 upon 4 whole square. Then we write minus 5 upon 4 whole square minus 3 outside. Now we have 2 x plus 5 upon 4 whole square minus 25 upon 16 minus 3. Now we'll multiply 2 by this and 2 by 25 upon 16. So when we will multiply 2 by bracket, it will remain outside the bracket. This will become 25 upon 8 and then minus 3. Then we have 2x plus 5 whole square minus 49 upon 8. We'll multiply 3 by 8. It will be 24, and minus 24 and minus 25 will become minus 49. So it is minus 49 upon 8. In second part, they are saying, hence write down the coordinates of the stationary point on the curve with equation y is equal to 2x squared plus 5x minus 3. Coordinates of the stationary point means turning point. We can easily write the coordinates of the turning point from this completed square form. As we know, there is a square on it, so the smallest possible value for this is 0. So if we equate x plus 5 upon 4 whole square to 0, then we will get the value of x as minus 5 upon 4. And when we will substitute here minus 5 upon 4, this will become 0. So we will be left with minus 49 upon 8. So minus 5 upon 4, comma, minus 49 upon 8 are the coordinates of turning point or stationary point. Third part is, on the axis below, sketch the graph of y is equal to absolute of 2x squared plus 5x minus 3, stating the coordinates of the intercept with the axis. It is the same expression which was there in the last part. So we already know the coordinates of turning point, which are minus 5 upon 4, comma, minus 49 upon 8. For y-intercept, if we take x as 0, here x as 0, then we'll be left with minus 3. So the y-intercept is at 0, comma, minus 3. Then we can take out x-intercepts, for which we will equate 2x squared plus 5x minus 3 to 0. We'll have here 2x squared plus 6x minus x minus 3 is equal to 0. 2x is common, x plus 3 minus 1 is common, x plus 3 is equal to 0. So we have 2x minus 1 and x plus 3. is equal to 0. So we have two values of x. X is equal to 1 upon 2 and x is equal to minus 3. Now, as we have to draw the graph of absolute function when the function is quadratic. So first of all, we have to draw the graph of this quadratic function. We have taken out y-intercept, x-intercept, and turning point. We can easily sketch the graph. We have 1 upon 2 and minus 3. We can consider 1 upon 2 over here, and we can consider 1, 2, and minus 3 over here. Minus 1, minus 2, minus 3. Then we have 0, comma, minus 3. We can mark minus 2, minus 4, and minus 6 here. Turning point is at minus 5 upon 4, means minus 1 whole 1 upon 4. So it will be somewhat here. And minus 49 upon 8 means minus 6 whole 1 upon 8. So minus 1 whole 1 upon 4 is here, and minus 6 1 upon 8 will be somewhat here. So now we will sketch the curve. As we have to draw a curve of absolute function, so we have to reflect the part of the curve which is below the x-axis to above the x-axis. So if this point is minus 3 here, so it will be at 3 here. And if this point is at minus 5 upon 4, comma, minus 49 upon 8, so it will be at minus 1 whole 1 upon 4, comma, 6 whole 1 upon 8. So it is to be. So we will reflect this part of the curve above the x-axis. So this part of the curve will be drawn like this. Once we have drawn the curve above the x-axis, we will erase the part which is below the x-axis. Now this is the graph this is the sketching of the graph which is required in part 3. Let's see what's there in the next part. It says write down the value of k for which the equation 2x squared plus 5x minus 3 is equal to k has exactly 3 distinct solutions. If we see x is equal to 0, then there are 2 solutions here. If we'll draw a line at x is equal to 2, then there are 4 solutions. But if we will draw a line at this point, the turning point, then we will get exactly 3 solutions, one here, another one over here. So the value of y at this point is 49 upon 8. So the value of k for which this has exactly 3 distinct solutions is 49 upon 8.